Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about two problems from Iran Math Olympiads from 1996. Let's take the first problem. For the first problem, we are going to talk about a problem that we got from two math competitions actually. It appeared in 1996 Iran Math Olympiad. It also appeared with a very small modifications in 2001 Korean math competitions. So you can tell this type of problem is a popular problem. Let's focus on the one that we got from Iran Math Olympiad in this video and see how we are going to solve it. In this problem, f of x is defined as 4 to the power of x over 4 to the power of x plus 2. And we need to find f of 1 over 14 plus f of 2 over 14 plus so on and so forth up to f of 13 over 14. Obviously, one approach is going to be replacing values that we have here in f and then get the sigma. But we are not going to do that, and it's not going to be easy to solve that way. So before moving forward to talk about the solution, take your time and we will see you in about 15 seconds. To solve this type of problems, you usually need to find a kind of symmetry in the expression that you are trying to evaluate. Here, the symmetry that we are looking for is going to be around what we have for 1 over 14 and then 13 over 14, 2 over 14 and then 12 over 14. As you can see, if we can have f of x, then we need to find f of 1 minus x, because 1 over 14 plus 13 over 14 is going to be 1. So let's focus on f of 1 minus x for a moment. We're going to start with replacing x with 1 minus x. The rest is going to be easy. We have 4 to the power of 1 minus x, and we have also 4 to the power of 1 minus x plus 2 in the denominator. As you can see, 4 to the power of 1 minus x can be written as 4 to the power of 1 over 4 to the power of x. If you replace and then do some algebraic simplification, you are going to end up with 4 over 4 plus 2 times 4 to the power of x. And you can just remove 2 from both top and bottom of this fraction, and you are going to end up with 2 over 2 plus 4 to the power of x. Now let's focus on what we have for f of x and f of 1 minus x. As you can see, if you add them together, you're going to end up with 1. Now let's focus on what we have. There is something beautiful here that I want you to understand really well. We have f of x, we have f of 1 minus x, and you add them together, you will get 1. However, in the expression that we need to evaluate, if you pair things together, you are going to end up with 1 over 15 and 13 over 15. That's easy. The same thing happened for 2 and 12, then 3 and 11, then 4 and 10, then 5 and 9, then 6 and 8. However, you are not going to be able to find anything for 7. Don't forget, if you add 7 and then another 7 here, you're going to end up with 2 7, but in the original expression we didn't have that. So you need to do something better here, and that's a beautiful trick and that we have in this problem. Let's see what we are going to do with that. So we are going to do a trick here. It says we have f of 1 over 14, 2 over 14, and so on and so forth. Let's define this as an expression like s. Now I'm going to write s in another order. So I'm going to start with 13 over 14 and I'm going to end with 1 over 14. Now if you add the one that we have on the above and the one that we have on the below for s, you're going to see that we have 2s, but this time you can say f of 1 over 14 plus f of 13 over 14 is going to be 1, and you are not going to face any issue here. So we have 2s equals to 13, and then s is going to be 13 over 2, and that's our final answer. Now let's talk about the second problem. For the second problem, we have another one from 1996 from Iran Math Olympiad. This is actually another interesting problem that I wanted to talk about it with you guys. So here we have x cubed minus 6x squared plus 13x equals to 1. Now we have another equation very similar to the first one. Here we have y cubed minus 6y squared plus 13y equals to 19. As you can see, the difference between the first equation and the second equation is just the constant value that we have. The first one is 1 and the second one is 19. Now it asks to find y plus x here. So to solve this problem, you need to do some tricks. We are going to talk about that, but first make sure that you pause the video to think about it and then follow what we have in the video. See you in about 15 seconds. To solve this problem, let's first review something that is kind of known for people. If you have a cubic equation like ax to the power of 3 plus bx to the power of 2 plus cx plus d equals to 0, and then if you replace x with a new variable like y, but in a way that x equals to y minus b over 3a. Remember, b is the coefficient of x squared and a is the coefficient of x cubed. If you do this replacement, then you're going to end up with another cubic equation, but here you don't have any coefficient for x squared. Basically, we have the same coefficient that we had for x cubed here for y cubed, but we need to find the coefficient that we are going to have for y and also the constant value that we are going to have. Here we show that by p and q. To summarize, you can remove the coefficient that you have for x squared here by doing a replacement. This is something that we are going to do to solve this problem. So let's see how we are going to benefit from this in a few seconds. Here we have x cubed minus 6x squared plus 13x, let's say minus 1 equals to 0. The replacement that I'm going to use is going to be x equals to t plus 2. The reason is the coefficient of x squared here is negative 6. Then if you divide that by 3 times the coefficient that we have for x cubed is going to be plus 2. Now let's use this replacement. For the first term, we are going to have t plus 2 to the power of 3, then t plus 2 to the power of 2 times negative 6, then t plus 2 times 13, and after doing some algebraic simplification, you're going to end up with t cubed plus t plus 10 equals to 1. Here, as you can see, we don't have any coefficient for t squared. We have the same coefficient that we had for x cubed for t cubed, and we reached some new coefficient as a constant coefficient here. Now let's go back to the second equation that we had from the original problem. We have y cubed minus 6y squared plus 13y, this time equals to 19. We are going to use the same approach, replacing y with a new variable like q plus 2, and algebraic simplification results in q to the power of 3 plus q plus 10 equals to 19. Now let's see what we've got. We have two new equations. They are using the same coefficients for power of 3, power of 1, and also power of 2. The power of 2 case is 0 here. But we have different constant coefficient. One of them is, let's say, 9, and the other one is negative 19. Let's focus on those. We have t cubed plus t equals to negative 9. We also have q to the power of 3 plus q equals to 9. Now let's define a new function like f of w and define it as w to the power of 3 plus w. Let's see what we have here. The function that we have is an interesting function. It is, first of all, an odd function, and second, it is an increasing function. So let's say we have f of t equals to negative 9 and f of q equals to 9. So first of all, you can say that t and q are basically negative of each other because the function itself is an odd function, and also it is an increasing function. So you can say that t equals to negative q. What does it mean for us here? It basically means if you add t and q together, you're going to end up with 0. Now t is x minus 2 and q is y minus 2. So if you add them together, we are going to have x plus y minus 4. And this needs to be 0. So x plus y is going to be 4. And we finally found the answer. Thanks for watching the video. I hope you enjoyed the content that we had in this particular video. If you are interested into more math problems from different math competitions, and also puzzles, please subscribe to this channel. Also let me know if you are aware of any problems that appear in different math competitions and you want to discuss that in these videos. See you in the next video.